Hello everyone, today I attended on a proposing oil well which is equipped with electric submersible pump or ESP. I want to talk about the differences between an ESP lifted well and a natural flowing well. I want to show you the difference between the surface equipment, surface facilities, and also the difference of the wellhead and expansory equipment. The first difference that we can see here is the availability of these two cabins. First one is the step-down transformer, which takes the high voltage power from the power transmission network and reduces its voltage to the voltage necessary for the VFD panel. I will show you the nameplate of this step-down transformer. You can see here that the rated capacity is 1250 kilovolt ampere. Rated voltage is 33 kilovolt to 400 volt. So it takes the 33 kilovolt power and reduces the voltage to the 400 volt and conveys the electricity via these two lines to the VFD panel. The VFD is an equipment that changes the frequency of power that sends to electric motor of ESP pump. So by varying the frequency and rotates the speed of the electric submersible motor will change, and consequently the flow rate and head generated by the pump will change as needed. Here we have a LCD that shows the parameters that is measured by ESP downhole sensor. We can see here output frequency to be 42 Hz, total electric submersible motor current to be 38 ampere, load factor to be 50%, efficiency factor to be 0.88, electric submersible motor to be 2469 volts. So, how the 400 voltage power get to 2469 volts? As I told you, the voltage of the power get out from this step-down transformer is 400 volt. So the input power of this VFD panel is 400. But as we see here, the voltage of the power get to the motor is 2469 volts. How? Yes, via this instrument. This instrument is the step-up transformer that increase the voltage of the power outlet from this VFD panel from 400 volts to the necessary voltage for the electric submersible motor. Other parameters that we can see in this panel are current rings, intake pressure, which is 167 atmosphere, electric submersible motor temperature, which is 91 degrees Celsius, ambient or intake temperature, which is 94 degrees Celsius, and also motor expired vibrations. All of these parameters are measured via electric submersible pump sensor, which is installed at the bottom of the string. Let's go toward the well and explain the differences between the wellhead expansory equipment of a natural flowing well with that of an ESP lifted well. So the power from the step-up transformer will carry through this line toward the wall. This line. This is the ESP surface cable which comes from the step-up transformer. And here we have another equipment that is called the junction box. Junction box is an explosion-proof container for connecting the surface cable toward the downhole cable. Why we need this explosion-proof container? Because the cable that comes out of the well can be or contain some hydrocarbon gases inside of it, and it can cause explosions. So we need to connect the downhole cable to the surface cable in an explosion-proof container which is called junction box. So this is the downhole cable that should go to the downhole. How it can go through the wellhead? I will show you. You see, the downhole electric cable goes to the wellhead and penetrates through this cable feed through and go through the specific ESP tubing hanger which has a hole inside of it. So, what's the name of this equipment? This flange is called the bonnet. The bonnet is an extra flange with respect to a natural flowing well that has a hole inside, and a cable feed through will passes the cable, ESP cable, through the wellhead toward the well. So let's explain about the other differences of an ESP well with the natural flowing well. For this purpose, I will explain all the flanges of the wellhead and Xmas free from bottom to top. The first flange you can see is the 8.58 inch casing head spool which welded on the 8.58 casing and seals the neck of 13.38 casing. And also it has a side valve that measures the any fluid pressure between the 18.58 and 13.38 casings. Above this flange we have another casing head spool which is welded on the 13.38 casing and seals the neck of 9.58 casings. Also these two sides valve will read or release the pressure of any fluid between the 9.58 and 13.38 casings. Above this we have another flange which is called tubing head spool. Tubing head spool is the place where the tubing hanger will set inside or seat inside of it, and also it have two side valves which will release and measure the pressure of any fluid between the tubing or completion string and 9.58 casing. The difference here is on this flange. This is another secondary tubing head spool which is specific of this well that due to installation issues and for the purpose of spacing up the Christmas tree for better connection of the flow line, they added an extra tubing head spool. So here on this well, maybe it's better to see from this side, we have an non-ordinary two or double tubing head spool. Above the tubing head spool, we have the bonnet that I described earlier that passes the ESP cable through the wellhead toward downhole. and this cable will go to the ESP motor depths alongside the tubing and connected to the ESP motor via ESP motor hotel connection. About the bonnet, we have the bottom main valve, we have the top main valve, we have two dipping valves, and on the right we have the production valve. We have a gauge, pressure gauge, which reads the wellhead pressure, wellhead flowing pressure, which is right now 650 psi. On the right we have an adjustable choke valve, which helps to control the flow rate of the valve and stabilizes the flow of the valve. And after that, the produced oil will convey through this production line toward this production valve and toward the production flow line. Another difference for this ESP valve is that a line connects the side valve of tubular spool to the production line. Why? Because in the downhole on the completion string we have a gas separator which separates the associated free gas that flows before flowing through the pump and conducts this gas to the anodes. So this gas that comes to surface should again flow to the flow line. So they installed the check valve here for preventing backflow of the gas or oil toward the anodes, and connect the side valve to the production line. So the gas will mix with produced oil and go through the flow line and transmitted to the manifold. Here we have another gate valve, and after that we have piston trap. It is placed here to trap any solid materials that come with the produced oil from downhole and prevent these solid materials via a mesh type pipe that is inserted inside this flange, and prevent these solid materials flowing toward the surface facilities. So the straight line is the line that goes towards the burning pit that you can see there. The perpendicular line is the production line which goes toward the oil manifold. This is an above ground flow line. So it's all about the surface facility of an ESP well and its differences with a natural flowing well. I hope this tutorial would be useful for you, and see you in the next tutorial.